Today I'm going to show you how to make an NMR sample. So here I have an NMR tube and a little bit of vanillin. So you're going to take the open end of the NMR tube and go straight down onto your product and then tip it back and just tap it on the table to try to get all your product down into the bottom of the NMR tube. You're going to need about 1/8 of an inch of product in your tube. So then, since this is a solid, the NMR machine will not run spectra on solids. It needs to be a liquid or solution. So I'm going to take a little bit of deuterated chloroform, because this will dissolve vanillin. And you're going to take about 0.7 milliliters of chloroform and put it into the NMR tube. You need about this much liquid. Even if you're running an NMR on something that's already liquid, you still need about 0.7 milliliters because that will bring the liquid line up to about here. And when you place it correctly in the machine, the magnets that are in the machine will be on either side of your solid and will get good spectra. So once you put it in your tube, you're going to invert it this way and back this way, and that will get all of the solid in your tube and dissolve it properly. So now that we have a sample that is already dissolved and ready to go, we're going to run it in the machine. So we're going to take this little thing here and we're going to slide our sample down the top and pull it all the way through until it stops. Then we're going to take our container here, we're going to slide it down, push the top all the way down. This will make sure it is the correct height to sit in between the magnets in the machine. So pull this out, and this here is the standard. This always lives inside the machine, and you'll only take it out to put your sample in. So you slide your sample in straight through the top and let it slide all the way down. Then you come over here to the computer. So here on the computer, there's two things that you'll use. There's the SpinSolve software and the MNova software. So today we're going to use the SpinSolve, and this is how you get your data. So there's two different kinds of NMRs you can run. There's hydrogen NMR and fluorine NMR. You can only run fluorine NMR on molecules that have fluorine in them. So since I don't have any fluorine in vanillin, I'm going to run a hydrogen NMR and then a proton NMR. So it comes up with this, and over here you have several different choices. There's the quick scan of 10 seconds. That will give you a really quick, fast spectra. If you want really sharp, clear peaks, then you're going to run a power scan of 10 minutes. Today, I'm going to run a 10-second spectrum. You're going to name your sample and choose which solvent is in your sample. So I have chloroform, and then I press start. So it's going to run the sample through the machine, rotating the magnets around it. You're going to read each functional group, each hydrogen on the functional groups, and it's going to spit out a data sheet right here. So this is your spectra from the NMR. That is an NMR of vanillin. So once you have that, you're going to go down here to the button that says MNova. Click on that, and that will transfer it to a different software that you can put peaks and different things on. So I'm going to get rid of all this junk right here. So go to Analysis, Peak Picking, and go down to Delete All. And then come over here, delete this one, and this one down here because you don't need any of that. So now you have a clean spectrum. So you go back to Analysis and go to Reference, Reference L, and you're going to decide which peak is your solvent peak. Now different things will have different solvent peaks. Today I used deuterated chloroform, which means it has TMS in it. TMS is going to come out at the furthest peak to the right. And so this little peak right here is going to be my TMS peak. So I click on that, and that's going to be set at 0. If you use regular chloroform, that will come out at a different peak. And so we use our handy little sheets over here, and that'll tell you exactly which peaks your solvent is going to come out at. But today, since I'm using deuterated chloroform, it'll come out at 0. So I'll do that, and it'll shift the peaks over to where it's a more accurate representation of where those peaks come out at. So now that I've done that, I'll go back to Analysis and go down to Peak Picking. go peak by peak, and I'm going to choose each peak that I want to reference. So I'll click on those, and those will give me an accurate number of where those peaks come out on the spectra. So I'll just choose each peak that has importance, especially these big ones right here. There's a lot of little stuff right here, and you can scroll up to make these bigger. All these little bitty peaks down here, that's just noise from the machine. Those don't matter. We just want to look at these main peaks right here. So after you've chosen your peaks, go back to analysis and go to integration and click manual. Then you'll start on this side of the peak where it's flat and go to the other side where it flattens out. And then this is a group of hydrogens that's going to be all on the same area. So I'll pick all of those, this big peak, and this one. Now integration is going to show you how many hydrogens are in those peaks or are represented by those peaks. These, since they're all about the same height, those are going to be about 1 hydrogen in those peaks because the numbers down here are all at 1. This one here is very close to 3, as you can see down here by the integration numbers. So since it's closer to 3, that means it's represented by 3 symmetrical hydrogens. So after you've done that, you go to View, go down to Tables, and Peaks. Then you're going to come up here and copy table and paste it onto your spectra. So now you'll have a summary of all the peaks on your table, and then you can save that and print it. Now after you've done your spectra, you're going to come back over, take your sample out of the machine, and put the standard back into it. Make sure you always do this, because it will keep the machine in good working order. Then to take your sample out, push down, and your sample comes right at the top. Put that back, and now your sample, since it has chloroform in it, it has chlorine in it. So it is a halogenated waste now. So we'll take it into the organic lab, dispose of the liquid in the organic halogenated waste, and you can put your old used NMR tubes right here in the beaker.